Hey there, and welcome! Today, we are going to tackle one of the absolute workhorses of trigonometry, the law of sines. So, have you ever found yourself staring at a triangle that doesn't have that neat little 90-degree angle and thought, now what? Well, this is the tool you've been waiting for.
All right, so here's our game plan for today. First, we're going to crack the code on what the law of sines actually is. Then, we'll talk about the exact scenarios where you'll use it. After that, we'll walk through a couple of examples step by step. I'll also show you the one super common mistake you've got to avoid. And finally, we'll connect all this math to the phone that's probably in your pocket right now. Sound good? Let's jump in.
Okay, so you probably got SOHCAHTOA down for right triangles, right? But what about all the other triangles out there? You know, the ones that are a little less perfect, the oblique ones. To solve those, we need a different kind of key, a sort of universal code that works for any triangle you throw at it. And here it is, the law of sines. It looks simple, and honestly it is. The big idea is this. The ratio of any side's length to the sine of the angle directly opposite it is always the same for all three sides of the triangle. It's this beautiful, constant relationship that lets us find all the missing pieces. So, you might be asking, when do I pull this tool out of my toolbox? Well, the law of sines isn't for every single situation. It's really the hero in two very specific scenarios. Let's break them down. These are your two green lights. First, if you know two angles and a side that is not squished between them, that's what we call angle-angle side, or AAS. The law of sines is perfect for that. And second, if you know two angles and the side that is right between them, that's angle-side-angle, or ASA. If you spot either of these setups, you know exactly what to do. But wait, before you even start setting up fractions, here is a pro tip that's going to make your life so much easier. In both of those cases, you already know two of the angles, right? So just find the third one immediately. Remember, all angles in a triangle add up to 180 degrees, so just subtract the two you know from 180. Trust me, get all three angles on the board first, and the rest is a piece of cake. Okay, enough with the theory. Let's get our hands dirty and actually solve a problem to see how this thing really works. All right, here's our first one, a classic angle-angle side case. We've got angle A at 40 degrees, angle B at 60, and side A, the one opposite angle A, is 10. So what's step one? You got it, find angle C. A little subtraction, and we see it's 80 degrees. Now we can set up our proportion. We use the pair we have all the info for, side A and angle A, so that's 10 over sine of 40. We set that equal to the side we want, which is B, over the sine of its opposite angle, B. Then it's just a little algebra to solve for B. You pop that into your calculator, and boom, you get about 13.47. See? So clean, so simple. The triangle is starting to reveal its secrets. That's the law of sines in action. Let's try an angle-side-angle problem now. This time, we know two angles, A and C, and the side that's right between them, side B. First step is always the same. Find that missing angle. 180 minus 50 minus 70 gives us 60 degrees for angle B. Now we have a complete pair. We know side B and angle B. That's our golden ratio. We can use that known pair to find side A, and then use it again to find side C.
And there you have it. We started with just an angle, a side, and another angle, and now look, we've found every single missing part. The whole triangle is completely solved. It's like being a detective for shapes.
So you're probably feeling pretty good right about now, and you should be. But listen, there is one tiny little mistake that I see all the time, and it can throw off every single one of your answers. Let's make absolutely sure you don't fall into this trap. It all comes down to this one simple question. What mode is your calculator in? We've been working with degrees this whole time, right? 40 degrees, 60 degrees. Well, if your calculator is secretly set to radians, it's going to give you completely wacky answers. So before you punch in a single number, just check your mode. Make it a reflex. It'll save you a world of pain. So, you might think this is just some abstract math for a test, but I promise you, the law of sines is working all around you in technology you use every single day. You ever wonder how Google Maps knows exactly where you're standing? A big part of it is something called triangulation. Basically, your phone's signal hits a few different cell towers. The network knows the exact distance between those towers. That's one side of a triangle. By measuring the angles your signal makes with those towers, it can use, you guessed it, the law of sines to create a triangle and pinpoint your location. Pretty cool, huh? So we have totally mastered the angle-angle side and angle-side-angle cases. We know they're perfect for the law of sines. But what if you're given a different setup? What if you know two sides and an angle that isn't between them? Side-side angle, or SSA. Can you still use the law of sines? Well, the answer is yes, but that's where things get a little tricky, a little ambiguous, and that's a fascinating puzzle we'll have to save for next time.